Good morning. You thought that you were done with me and with biology, but never. So, we're just continuing on with the Unit 2 Paper 5 questions, okay? And the last question that we were looking at is, if you remember, to do with genetic cloning, selective breeding, the story of Toy Story, the bull, okay, which you were all very amused by. So I think the last thing we did was part G. Have I uploaded the mark scheme? I will double check. At the time that this video is uploaded, the mark scheme will absolutely be there. However, I recommend that you do this, you take this seriously and you do it without the mark scheme and then only use the mark scheme to self-assess your work. The point of me going through these questions is basically just to explain the science behind it, any tips and tricks. So you can, if there is a particular question, you can fast forward to that question. So, last part of this first question we were doing about Toy Story the Bull is give two advantages of using cloning rather than selective breeding to produce offspring. Now, first thing that I want to think about there, we've got cloning, we've got selective breeding. How many parents does cloning involve? And how many parents does selective breeding involve? And what does this mean for the level of genetically, identicalness is the word I was looking for. What does it mean for genetic variation is probably a better way of saying that. So, cloning, you only need one parent and you produce genetically identical offspring. So, produce genetically identical offspring. Hold on. Okay, I'm hoping that you have come to the conclusion that you only need one parent for cloning, whereas you need two parents to reproduce with selective breeding. Plus, with selective breeding, you have to first of all let the animals mate or breed them together. Then you have to let pregnancy happen, okay, until they give birth. Now, in theory, you still have to let pregnancy happen with cloning because you put the embryo, the modified embryo, back into a surrogate, okay. However, it is still a faster process, okay, because only one parent is needed. Therefore, it is a faster process. Done. So that is all of question one done. The other two images that we did in class, I will upload so you have them as well. You can see our answers and how we marked it. Right now, let me fight with this camera a little bit. Here we go. So a scientist uses this method to investigate the effect of water quality on the growth of fish. Okay, so we are thinking about water again. Okay, and we're thinking about fish. This is our unit 5. So they filled a pond with filtered water. Oh, how nice that they had that much filtered water to fill a pond with. Another pond with unfiltered water. They placed the same mass of fish of the same species. So they've already controlled that same mass, same species. That's two control variables. And they looked at the increase in total mass of fish in each pond after 180 days. Now, although I haven't even read the question yet, I would like to, we're thinking about this experiment, and I would really, really like us to get into this mindset whenever it comes to a question about data or experiments, okay? Just identify for yourself the variable. So obviously an independent variable is the thing that you change, dependent variable is the thing that you measure, and control variables is the thing that you keep the same, obviously, right? So we've just highlighted the true control variables. So these are control. There's two of them, 1 and 2. Okay, we're measuring the mass, the total mass in fish after 180 days. So this is my dependent variable. Okay, and I am changing the type of water. So this is my independent variable. All right, just making a note for myself there. It might be relevant, it might not be relevant later on, but there's no harm in identifying that. So it says here then, the mean rate of increase, sorry, I don't know why my paper's wonky, hold on. The mean rate of increase in total mass of the fish in the filtered water is 0.214 kg per day. Calculate the difference between the mean rate of increase in the total mass of fish in filtered and unfiltered water. So we know what it is in filtered water, the mean rate. Okay, so we've got the increase in total mass in kg. Okay, mean rate. How do you think we have figured this out? So we've got here, so this is filtered water. So if I read off of this, we have, what is this? Let me read this. 35, 36, 37, 38, 38.5. Yes, so I would say this is 38.5 for this one. Okay, and let me have a look on the unfiltered water. Oh, obviously, if they've told us filtered water, we only care about the unfiltered. So let's have a look at unfiltered. Where are we? This is 25, 26, 27, 28, 28.5. 28.5. So there's been an increase in mass. Increase in mass. For this is for the unfiltered, yeah? Unfiltered. 28.5 grams. Okay, now 28.5 grams, we want this in a rate, okay, in a rate per day. How many days did they say that they measured after? What's that? Did I hear you think 180 days? Yes, I did. Thank you. Okay, so 28.5 divided by 180 is, let me check my calculator because I have no idea, 0.158. Okay, this is my rate, which is kg per day. Yeah? All right, and now it wants the difference. So if it's already told me 0.214 over there, okay, so I'm going to do, do you think I can squeeze it in over here? Let's see. No, I won't. Shall I? No, I'll do it here. 0.214 take away 0.158 equals, hold on, I want to do this mentally, and I don't think I'm going to do it very well. 0.056. Let me check this, hold on. Haha! I am correct. Okay, 0.056. Okay, and that is the difference. Khalas, done. Boom. Answer. Whenever there is a rate, by the way, just as a little tip, whenever there's a rate, you're always dividing something by time. Always, always, always. Whether it's volume by time, mass by time. I don't know what else there could be. What else is there? Volume, mass. Yeah, that was about it. Right, so you're always dividing by time, okay? Done. That's that question. Next one then. It says unfiltered water contains more bacteria, okay? And explain why unfiltered water containing bacteria affects the growth of fish. Now, we know this. What are the bacteria? What's the bacteria going to do? Bacteria is going to use bacteria. Okay, now this is 3 marks, okay? So let's explain it in a logical way. So bacteria are going to use up the, well done for thinking that, if you thought that, the oxygen for, well done, respiration, and therefore, should we be fancy and use a semicolon? Let's be fancy and use a semicolon. Okay, therefore, there is less oxygen, that's right, O2, for the fishies, the poor fish, for the fish to do their own, what's the word? What do they need to do? Less respiration for the fish, so they themselves do less respiration. Okay. Or you can actually not do less respiration. It sounds a bit, doesn't sound very smart. So they respire less, is what we can say. Okay. And then, although there's more lines on the next page, I'm just going to squeeze in the rest of my answer over here. If there are bacteria in the water, what can bacteria cause in fishes or fish, any living organism? Okay, so you can say this is one idea, and then we would say bacteria can cause disease. Okay? Or should we say more disease? Let's just be careful because obviously might be bacteria or other things that can cause disease in general. But let's say if you have unfiltered water, there's more bacteria, so there would be more disease. Okay, beautiful. Let us move on to the next question. What is the next question? Okay, the next question is give one biotic, variable the scientists controlled in the investigation. Controlled, so not meaning they've already told us this, yeah? What have they controlled? And biotic, living or non-living? Living, well done. Okay, and so what did they mention over here? Look, it told us in the question. We highlighted it, and look, it was relevant. Same mass of fish or same species, because obviously the fish is the living thing here. So up to you. You can say mass or you can say species of fish. Whee. All right. Now, give a method the scientists could use to control interspecific predation in ponds. Okay. Now, interspecific predation. We've never heard this before. Now, specific meaning species. Now, inter, does it mean between or does it mean within? If I said there's going to be an interform competition, does that mean that it is between forms or within forms? If I say that there are intermolecular forces between, I will not continue that sentence. Oh man, I just told you the answer. Intermolecular forces are within molecules or between molecules? If you caught what I said, okay? The prefix inter means between, always, okay? So basically, how can they control other species of fish from being predators preying on this fish that they're investigating? Okay, so they could use some kind of if they want to keep their fish safe in the pond, they might want to use a net around the fish, so then the predators can't get to them. Or they could just kill any predators, okay? Or kill predators, okay? Or scare them away. Because if you think about it, in ponds, the biggest predator is what? What can swoop down from the sky and pluck them out of water? Birds, right? So you could make some noise, something like some kind of noise machine to scare them off. You could just shoot them down. That sounds a bit violent, but you know what I mean. Kill predators. Or if you had a net on the surface of the pond, so actually they can't get to the fishies. Okay, we need to protect the fishies for our investigation. All right, perfect. Now we will move on to another extract question because I know how much we love them. So this one is about badgers and bovine tuberculosis. Now, tuberculosis, have you ever heard of it before? I hope you have. It is a bacterial infection, okay, that happens in the lungs and can occur in lots of different animals as well as humans. In this case, we are thinking about bovine, meaning cattle, okay? So I will not waste this precious limited recording time that I have by reading this whole extract for you. I will just hope that you can read this and we'll pause here and read the extract for yourself. Please read the extract for yourself. I am just going to go through and read it in my head and just underline the things that I think might be relevant. So we've got a bacteria here. Infected cattle, so obviously the damaged lungs, okay? Gas exchange problems, coughing, okay? And then it can spread to humans. Oh, gross. If they inhale air or if they drink the unpasteurized milk. You know what this word unpasteurized means from Unit 5. Pasteurizing milk is when you heat it to high temperatures, okay? And that normally kills any bacteria, right? Oh, look, it tells you there. Milk is usually pasteurized by heating it for a period of time at a high temperature. So if you were to drink this milk before it was pasteurized, that bacteria would still be in it and you can get infected, okay? Now we've got this idea that it can kill humans, and we've got a whole bunch of statistics there that I will not read in this instance, but I have read it in my head, okay? So we've got in Europe and outside of Europe. This could be relevant later on. And then now we've introduced another animal into the situation because farmers in the UK are concerned that badgers spread this pathogen to the cattle. So they themselves carry it, um, not even showing signs themselves, but can pass it on to the cattle. Okay. Right. So, right. So some farmers they want all badgers to be killed. Ooh, it's a bit aggressive, isn't it? Um, and then, but some scientists claim that actually not as many cattle as you would think. Like it doesn't all come from badgers. So killing badgers would drive the rest of the badgers out, and they could go to new areas. Okay. Um, hmm. This is very fascinating. But I did not know this about badgers. They are very territorial. Okay. And if you cull them, then their territories cannot be defended, and then new badgers will move in, and they could bring TB with them. So rather than them spreading it, them leaving the area and spreading it to other areas, new badgers could come in and bring it with them. Okay. Other people believe that badgers should be vaccinated, so either kill the badgers or we vaccinate the badgers. Okay, so we need to find out if this badger vaccination can reduce TB in both badgers and in cattle. So, first question. This is from Breathing and Gas Exchange, Year 10, but it's also Unit 2. Okay, so, Unit 2, that's what the U2 is for. Right, explain why cattle with damaged lungs have gas exchange problems. What is the site of gas exchange in the lungs? What structure actually is where the oxygen and CO2 is exchanged? That is correct, the alveoli. So, it damages, this TB damages alveoli. And what do you think the biggest problem would be? Um, does it say it here? Lines 2 to 3. Lines 2 to 3. It does not. However, what is the function of the fact that we have hundreds of alveoli or millions of alveoli in our lungs? It gives the lungs a large surface area. So therefore, if you are damaging alveoli, this which reduces surface area. And therefore, oh look, we're using therefore again. There is less, how are gases exchanged? Very good. Oh, there is less diffusion of, let's say, for example, O2 in, or you could say CO2 out. Okay, that's our gas exchange. Done. Fabulous. Pause if you need to copy something, okay? Right, moving on to the next question then. Okay, so it says here then, explain the advantage of drinking pasteurized milk rather than unpasteurized milk. So we said this already, okay? So if we heat up the milk, what will die? The TB bacteria. Very good. So heating the milk, i.e. pasteurizing it, will kill, to be honest, not just the TB bacterium, but actually all bacteria. But anyway, we'll kill the bacteria, which reduces the chances of catching it, yeah, of infection. I hope that one was pretty obvious. Right, now it says suggest 2 reasons why there are few. This is only 2 marks, by the way, over here. And we are just stating the obvious over here because it's an explain question. It's AO2 at most. Okay, now here, this next question is a suggest. Remember, as soon as you see the word suggest, this is AO3. It is not going to be immediately obvious. Okay? You have to think outside the box here. So it says suggest 2 reasons why there are fewer cases of bovine TB in Europe compared with outside of Europe. Okay, so what might there be more of outside Europe compared to inside Europe? That would mean that there are more cases outside, more bacteria to be spread. So first thing maybe we could say that there are fewer cattle outside Europe. Is it outside Europe? No, in Europe. Sorry. Fewer cattle in Europe, potentially. Okay. Or maybe in Europe, this is something that sounds something that they would do. Perhaps let's link it to this question. Maybe people in Europe, more people in Europe, drink what kind of milk? Where is it on here? Okay, so maybe more pasteurized milk. pasteurized milk is drunk in Europe. What else would reduce the spread of disease in Europe? Um, Oh, what's the animal that's spreading the TB bacterium in the first place? Did you think badger? You are correct. So, do we think that there would be more badgers in Europe or less badgers? Less badgers. Good. So maybe there are less badgers in Europe. Also, there's only 2 marks, by the way. And I've written 3. Okay, I'm putting question marks as in like this is the idea that we're suggesting. Okay, and then maybe in Europe they have other ways of dealing with the infection with the infected cattle. Remember from fish farming, what do we do if a fish is infected? You know this. There's 2 or 3 possible things we could do. We could either remove the infected cattle, or we could give the cattle antibiotics. Well done. So maybe inside in Europe they remove the infected cattle or give them antibiotics. This is in Europe, yeah? In Europe. Okay, beautiful. Right, so now it says here the case to death ratio in Europe is 12.5 to 1. Okay, calculate the case to death ratio from outside Europe, meaning how many number of cases are there and how many people actually die from it. So what lines are this? 7 to 9. 7 to 9, where are you? Okay, outside Europe. Oh no, we have to do some maths here. So, 103 people died from 1,290 reported cases inside Europe, and the total reported cases is 149. Oh my goodness gracious, we have to do a lot of maths here. And then this is the total number of people who died, and that's the total number of people, the total number of cases, and we need to just do some subtraction. Right, so for number of people that died, we need to do 13,400 take away 103. And for the total number of cases, we need to do 149,000 take away how much? 1,290. Now I need my calculator for this because that's a lot of maths for my brain. Okay, so hold on. I'm gonna write this over here. Okay, so what was I saying? 1, 3. Oh no, I forgot the numbers already. 1, 3. No, that's a lie. 1,3,400 take away 103. This is the number of deaths, and the cases was 149,000 take away. Is it thousand? There was another zero, wasn't there? 1290. Okay, and according to my calculator, this one is 147 and then 147,710, and this one is 13,297. Right, so now as a ratio, we need to do case to death ratio. Which one was the case? This is the case, and this is the death. So it is 147. Oh no, I forgot a 7. Hold on. It's another 7 here. You know what? I'm gonna do that again. Okay, so to make, remember, we want to make this one, the second number, which is the death. We want to make that number 1. So we have to divide 147. Okay, divided by this number. Okay, which gives us 11.1 to a 1 ratio. So this gives you 11.1, and we've obviously just made the death 1. So this is our ratio. Well, actually, give me 11.1. Let's not confuse matters. So 11.1 to 1. Might just say 11 to 1, because that's really... Don't like that there's a dot there. That's disturbed me. Lots of ones. It looks like I don't know, some ancient symbol. Okay, anyway, I'm disturbed by that one. Anyways, right, so E, territorial behavior reduces the spread of diseases between badger groups, as they told us already. Now, again, another suggest, AO3. AO3. All right, so suggest two other ways that the badgers benefit from territorial behavior. Meaning, why do they protect their territories? What would it help them protect or keep safe? Yeah. So protecting, what do you think adult badgers will be protecting? Did you think that they would be protecting their baby? Yes, you are correct. Protect their offspring or babies. We can call them babies. Let's call them babies. Okay, the young. And then also they can, if they're protecting their territory, their area, there's less competition for. Um, did you think food? You would be correct for food. Less competition for food. Okay, beautiful. Also, they could protect. They want to protect the babies, and they also want to protect the ability to have babies. So they need to protect their females or their mates. Yeah. So technically, that's three separate marks there, and it's only a 2-mark question. So you can just pick two. Okie dokies, right. So it says explain how vaccination reduces the risk of infection in badgers. This is your unit 2. This here is, I know it says explain, but it is AO1, memorizing. Okay, vaccines. First of all, you insert, or inject, sorry. What form of pathogen? This should be, like, listen, any question about vaccinations, especially if it's explaining how vaccinations work, the answer always follows the same structure. So you can just memorize it. Okay, so inject, weakened, or dead form version of pathogen. Okay. Once you've injected that, you can bullet point your answer, by the way. What do we call this stuff? So if this is my pathogen, pathogen. What do we call these things on its surface that are recognized as foreign by the immune system? Starts with an A. These are terrible drawings, but we call this an antigen. So its antigens will be identified by what? Now, by, hold on a second. Right. Reduces the risk of infection in badgers. Okay, I'm just thinking if we can take the short answer here. No, will be identified by, let's just say, by lymphocytes. Okay. It's only 3 marks. Let's take the short version actually. Its antigens will be identified by what type of cells were already in the. No, let's not take the short answer. Sorry, this is me thinking out loud. Let's follow the full pattern so that you know how to answer this question, okay? So antigens will be identified by lymphocytes, which will make. What do they make? What do lymphocytes make? Antibodies, okay? And memory cells will also be formed and remain in the blood, okay? So for every single type of antigen that you're infected with, your memory cells are formed, form and remain in body. Okay, now, if you are reinfected, oh no, I didn't leave myself space. Okay, if reinfected, the white blood cells will make antibodies, will be produced faster and more of them. So maybe I should put it here. More antibodies will be produced faster. So that's actually usually is 2 separate marking points, one for faster, one for more. But some mark schemes can be harsh and make it 1 mark. So I think this mark scheme is a bit harsh, has made it 1 mark, but we've got 1, 2. So we've got, look, weakened, dead, that's 1 mark there. Antigens is another mark. Lymphocytes, nope, we've got memory cells is another mark, which is 4. And then reinfected, more antibodies produced faster is 5. Is that 5? Yeah, 1, no, it's 4. Sorry, 1, 2, 3, 4. Okay. And then, when the antibodies are produced faster, because it's the second time that you've been infected by the the same pathogen. We call this one the secondary immune response. Okay, and some mark schemes will give that as a mark just for calling it that. Okay, and some mark schemes don't. Life is hard sometimes.